You guys put stuff away, please. Okay, so what we're doing today is looking at prisms. A prism, by definition, is a solid with two congruent bases. And the other sides are rectangles, or the other faces are rectangles. I don't like to get into this as much as the book does. The book is going to ask some very specific questions like what are the lateral faces, what's the area of all the lateral sides. I'm not going to have you do that. We're just going to do total surface area for all of these. The lateral faces are the non-bases. It's all the rectangles that are around like the side of the prism. So for this prism here, this hexagonal prism, there are 6 lateral faces, 6 lateral rectangles that are all congruent, and then there are 2 bases. So the bases are the ones that are parallel. There's 2 of them. They're congruent. In this case here, it would be the hexagons. If it's a triangular prism, the bases would be the triangles. If it's an octagonal prism, the bases would be the octagons. Looking at this one here, this is called a right prism because the lateral faces are perpendicular to the base. All of these would be like right angles here. Over here, this is called an oblique prism. When we're doing surface area for this class, we're going to do surface area of right prisms. We won't be finding surface area of oblique ones. Those are going to be, they'd be more complicated than the ones we're doing. So when we're finding surface area, what we're doing is we're just finding this total area of all of the surfaces. And if you want to think of it that way, that's totally fine. If you don't want to use the formula, you don't have to. I like the formula because I understand it, but I could understand like if you just think it's another formula to know, where it might be kind of tricky. So I'm going to show you a couple different ways that you could do these, and you can decide which way you think is going to work best for you. The surface area of a right prism, you need to find the area of every surface. And if you want to do that and just list it out and then add them all up in the end, that's fine. Or you can use the following formula. The formula for surface area of any right prism is you can find the area of the base. And how many of those bases are there going to be? 2 of them. So if you found the area of the base and you multiplied it by 2, that would be part of what you need for surface area. So this capital B in the formula stands for the area of the base. So you find it once and double it because there's 2 bases. And then you're going to add to that the area of all of these rectangles. So instead of finding the area of one rectangle separately, because there could be a different number of rectangles for each one, they say the general form for the equation is you can find the perimeter of the base and multiply it by the height. So let me kind of show you what that would mean. Go to the document camera real quick. Oops. Let me see if you guys can see this. So for this triangular prism, there's 2 bases. The perimeter of that base, if I were to take this out and like lay it flat, the perimeter of the base is the same thing as like the length of this rectangle if I take those pieces and just kind of stretch them out. You guys all see that? So instead of finding the area of like one of those rectangles and then multiplying it by 3 in this case, I could just add up that entire length and multiply it by the height of the prism. So that's the way the formula is. Again, if you'd rather just find the area of one of those and multiply it by 3, you'll get the exact same answer, and that's fine. So either way that you want to think about it is okay. The perimeter of the base is the same thing as like the length of that entire rectangle if you were to lay it flat. I'll show you with the pentagonal prism real quick. If I can get. Okay, so same thing here. Now there's 5 of those little rectangles, but the length of that entire big rectangle, if you think about it that way, is the same thing as the perimeter of whatever that base is. Can you guys see that? Understand? Okay, so let me go back here. Okay, so for this prism, I'll show you both ways. We could either find the area of every one of those rectangles and then just add all those together. So for surface area, you have choices with what you want to say the base is in this case. Because it's a rectangular prism, there's not one, just like one correct base. Usually when it's a rectangle prism, kids say the one on the bottom is the base, but it doesn't have to be. You could say like this one over here is the base, or the front part's the base. If you're using the formula, you would have 2 times the area of the base. What's the area of that rectangle? 36, because it's 9 by 4. So 2 times the area of the base plus, what is the perimeter of that base? What is the perimeter of that rectangle?
26.
How'd you get 26?
9 plus 9 plus 4 plus 4.
Okay, so 9 plus 9, 4 and 4, they all add up to be 26. And then the height is the height of the prism, or the height is the height between the bases. The distance between the bases. I guess I should have labeled this. P is the perimeter of the base. So what is the height in this prism? 6. And what that does is that takes care of the area of all of those faces. It just takes care of it all together in one time. So 2 times 36 plus 26 times 6. When you multiply all that together, what do you get? Grab your calculator, what do you get? 228, and that would be square feet because we're talking surface area. If you would like to do those parts separately, you could. If you want to find like the area of the top and bottom, well, that would be the 9 by 4, so that's 36, and you just double it. If you want to do like front and back, well, the front and the back dimensions would be the 9 by 6, so that's 54, and you double that. And then if you wanted to do the left and the right, what are the dimensions of the left and the right? Well, that's the 6 by 4, so that's 24. So you could do 2 times 24 and then just add all those up. So either way, whichever way makes more sense to you, it doesn't bother me, you know, which way you kind of want to use. The formula, I like it because you can apply it to anything, any type of prism, and you don't need to worry about, you know, how many sides there are, but just adding them all up works also. And I've had students like both ways, so find the way that you think is going to work for you. For this next one, for this triangular prism, it's really important that you pay attention to which side is the base for this, because the base does not have to be the side that it's like sitting on. Okay, it has to be the side that's like the same cross section the whole way through, or it has 2 congruent parallel parts. So what is the base of this triangular prism? The base is this triangle. The lateral sides are all of those rectangles, those 3 rectangles that are kind of this way in the picture. So usually if it's not a rectangular prism, Rectangular prisms are pretty easy. You guys have been doing those for some time probably. If it's not a rectangular prism, I like to draw the base out separately and find the area and perimeter of that base separately and then plug those into the formula. So what are the dimensions of that base? Well, this is 12 and 12, and then since I'm going to have to find perimeter, I'm going to go ahead and just find the length of this side. You could use Pythagorean theorem, you could use sine, cosine, tangent, because this is a 45, 45, 90, or I would just know that that is 12 radical 2 because of the 1 to 1 to square root of 2 ratio. If you need to do Pythagorean theorem, that's totally fine. The area of this base is half of 12 times 12. So you can just grab your calculator, write these numbers off to the side. Half of 12 times 12 is 72. So the area of the base is 72. The perimeter of this base is 12 plus 12 plus 12 radical 2. And this is not a final answer, so please do not round this off. I'm going to write 40.9706. And it'll be very helpful to you if you have your calculator and you're typing this into your calculator, making sure you know how to get this. So I'm going to use the formula. Again, if you don't want to use the formula, you don't have to, but you still have to come up with that this is 12 radical 2. So you could find the area of this like diagonal piece. So the formula is 2 times the area of the base, so 72, plus the perimeter of the base, times the height of the prism. The height of the prism is the distance between these bases. How far is it between the bases? The distance between the bases is 8. So the height of the prism is 8. Sometimes students like to think about this and they like to think about it like just rotating up so that it's sitting on the bases. The height is not always like the number that's vertical on your picture. So I'm going to type this into my calculator. I would start, because I already have that 40.9 number, I would start by just multiplying that by 8 and then adding that to 2 times 72. So take a second to type that into your calculator. Hey, did everybody get 471.8 approximately after we round? Okay, so the surface area of this rectangular or regular hexagonal prism, for this hexagonal prism you have 2 hexagons. The area of the base is going to be the area of this hexagon, so if you want to draw that hexagon out separately, I think that might be helpful to you. We want the area of this base and also the perimeter of the base. The perimeter of the base I can find quickly because the side is 5. So I would do 5 times 6. The perimeter of that base is 30. The area of the base is half the apothem times the perimeter. I don't have the apothem, but I do have the perimeter, which is 30. So the apothem, we're going to use, same thing like we did in the last chapter, this right triangle. If you're looking at that right triangle, this portion here is 2.5. This is a 30-degree angle. So if you know that ratio, 1 to square root of 3, you could use that. If you don't know that ratio, you could use tangent. Tangent of 30 equals 2.5 over x. I like the ratio. I know that that's 2.5 times the square root of 3. If you get that as a decimal, it's about 4.3301. So that's the apothem. You can multiply that by half and 30. So the area of the base, and I'm going to write it down here, is 64.9519. I understand that that takes a little bit of work to get to that stuff, but once you have that, if you're using the formula, you have everything you need and you just take those numbers and plug them into the formula. So you kind of do a lot of the work up front, and then ending the problem is just plugging numbers into the formula. So the surface area equals 2 times the area of the base plus the perimeter of the base times the height of the prism. So that's going to be 2 times the area of the base is 64.9519. The perimeter of the base is 30. And then what's the height of the prism? Or what's the distance between those bases? 12. So I'm going to multiply that 64 number by 2 and add on 30 times 12. And that's going to be about 489.9 centimeters squared. So any questions on that one? Type that into your calculator quick. Make sure that you're getting that. Okay, for the cylinders are pretty quick. For the cylinder, we have a right cylinder and we have an oblique cylinder. Just like with the prisms. The surface area of the cylinder is the same formula, except now what shape is the base for the cylinder? The circle. So instead of writing capital B for area of the base, you can actually just write out what that is. What is the area of a circle? Pi r squared. So they're going to write this out as 2 pi r squared plus the perimeter of the base is the same thing as the circumference of that circle. So what's the formula for perimeter of the base or circumference of a circle? 2 pi r times the height. So then you can take these numbers and just plug them into the formula. These are usually easier for students because you're just finding what the radius is and you're finding what the height is and plugging numbers into the formula. You're going to want to make sure you're typing them into your calculator correctly, but other than that, they're not too bad. So surface area of this one, what do you have? You have the diameter. What is the radius? 7.5, and the height is the distance between those two circles, or 18. So I'm just going to plug these into the formula. So 2 times the area of the base, so 2 times pi 7.5 squared, plus perimeter of the base, so 2 pi r, times the height of the prism. So take a second to type that into your calculator. I like to just type all of this in one shot into my calculator. So 2 pi times 7.5 squared plus 2 times pi times 7.5 times 18. You should get about 1,201.7, and that's square millimeters. For this next one, they give you the radius, they give you the height, so again, you're just taking these numbers and plugging them into the formula. Pi times the radius times the height. Make sure that you're able to get these correct when you type them in. But other than that, hopefully these aren't as bad as the prism ones. Should get 2,814.9, and that's square feet.